Yeah, so whilst I was doing the other video, it was started raining, so I think the later part there was noise and I think he didn't really hear it well. Okay, so let me kindly go over that part. Okay, then we will see what we'll do. Okay, so let me write stuff. Okay, so here this part is probability that x is less than 6.5. okay, right, but this part is between 6.5 and 9.5, so that is probability that, all right, we have 6.5 here less than x, all right, less than 9.5 and close. Okay, and remember how to write this. If you are writing this, you write it like probability that, bracket open, x is less than 9.5, okay, bracket close, minus probability that x is less than 6.5. okay, in my 6 what's up. So this is it. Okay, x is less than 9.5 minus x is less than 6.5. This is how you write this interval. Okay, this interval. So you know how do you do this? This is that you slot the 9 inside this, so you have here 9.5 minus 12 over, right, (9.5) minus 12 over 4. Okay, that's what you get. So that will be the value here, and then when you do the same thing to that value will also be there. Okay, so you look for this value on the table. All right, so now you'll be looking at probability that z is less than whatever value you get from this. So maybe I don't really know the value. All right, so the value you get, just write it down. Okay, then go and look for it on the z table. So this is the z table. So if the value was negative, maybe you had something like negative 1.0, see the top there is numbers, so 1.01, 1.02, 1.03, right? So if it is, let's assume it is, you had negative 3.1, let's say 3, so that means you go this way and pick this probability. Okay, yeah. So you do the same thing to this part. It's also between 12.5 and then 6.5, so you subtract. All right, so the same thing, you this part, the same thing, this part will be probability that x, or let's use z. Okay, z is less than, then less than what? This value. This will be the first value which will come 15.5 minus 12 over 4. Okay, over 4, and you close minus. Okay, so this is that minus probability that, right, z is also less than this value, so you have 12.5 minus 12, right, all over 4. Okay, all over 4, bracket close. All right, so this value will give you some value. Okay, so you go and look for z less than that value on the table. Okay, and then z less than this value on the table, and then you subtract, and that will be the probability which will be here. Okay, so you do the same thing to this. You do look for this. When you put 18.5 here minus 12 over 4, you go and look for the value on the z table. 15.5, you go and look for value on the z, subtract, and that will be the probability here. This is greater than. Okay, so here is greater than, here is probability that x is greater than 18.5. all right, 18.5. so to do this, this is saying that is equal to 1 minus, okay, probability that, and now you change it to z. Z is less than, okay, 18.5. so 18.5 minus 12 over 4. Okay, over 4. You close. So you go and look for this value on the table and subtract from 1, and then that will be the probability recorded here, right? And then you consider rule of 5. So it happens that this value, when you got the probabilities, you have to find expected frequencies, which is 40 times pi. So 40 times this is 3.3, 40 times that is 7.0, 40 times that is 11 point that, 40 times this is that, 40 times this is that, 40 times this is 2.064. okay, so when you are done, you check this is less than 5, so you add it to this to get this. This is okay, this is okay, this is okay, but this is less than 5, so add it to this to get that. All right, so when you are done, these are the expected frequencies. So it means you do the same. What you do here, you have to come and do the same thing. So you add this to get a 7. All right, this is 15 and 10. You add this to get an 8. That's fine. So when you are done, you can go ahead and find your test statistic using the FIs. Now your FIs are ready. Your FIs are ready, and then your EIs are ready. Right? So you go ahead and look for your test statistics by using the formula. Okay, and then your test statistic is this value. Okay, and then now your degrees of freedom, remember that the numbers has reduced. The whole categories were 1, 2, 3, 4, 5, 6, but just that you've combined some of the categories, so we have only 1, 2, 3, 4. So your k here is 4. Okay, so k is 4 minus 1, and c is 0. I said it in the earlier video, c is 0 because that we didn't estimate any parameter. All the parameters were given, the normal distribution parameters were given, so we didn't estimate any parameter. Okay, so that is that. So that's our degrees of freedom of 3. So we have chi-square 0.025 degrees of freedom 3. Remember that was the alpha value that was given, and now degrees of freedom is 3. So you go to the chi-square table. This is a chi-square table. Degrees of freedom 3. All right. degrees of freedom is 3 is this part, and then 0.25 is this. Okay, so that's where they intersect. 9.348. Okay, so that is that. So that is that. So that ends this. Okay, so these are typical examples. So a computer used by a 24-hour banking service is supposed to randomly assign each transaction to one of the 5 memory locations. So a check at the end of the day transaction gave the following count to each of the 5 memory locations. Okay, is there sufficient evidence that to indicate a difference in proportions of the transactions assigned to the 5 memory locations? So here, these are the frequencies that they observed. Okay, so if you are testing to see whether there is no difference, it means that the expected frequencies has to be the same. Okay, the expected frequencies has to be the same. So remember here, n wasn't specifically stated in the question, so you can sum this up and see what n is. Okay, you sum this up to see what n is. All right, so for this kind of question, the probabilities are equal: 1/5, 1/5, 1/5, 1/5, 1/5. Right, then you multiply by the n by summing this to get your EIs, and then find your test statistic, and then you'll be fine. So this is another one. You're also trying to check whether this follows a Poisson distribution. So here too, you have observed during a 60-day period, so it means your n is 60. So when you sum the whole of these frequencies, you get 60. All right, so test whether it follows a Poisson distribution. So you have to quote the Poisson probability formulas, because that's what you want to use to find your probabilities, PIs, and multiply by n to get your EIs. But before that, remember that the Poisson distribution need one parameter, okay, mu. So this question didn't give mu, you have to estimate. So estimating it means your C will be equal to what? A 1. You have to estimate by using this. Okay, so you look for f of x, summation of f of x over summation of f, that'll be your mean, and then you use that one as your mean. So you have estimated some parameter, which is, so make your C equal to 1. Okay, so the same thing. So here too, experiment that was repeated 100 times. The number of repetition on a given day of success is recorded as below. Given that the probability of success in a trial is that, so here they're giving you the probability of success, and you know n as n, so you are not estimating anything. It's binomial. You know, binomial, the parameters are n and p, so all those has been given. So C is automatically what? 0. Okay, so you will use the binomial distribution to find the probabilities and multiply by n to get expected frequencies, and then do the work. So this is a normal distribution like the one we did. Okay, so after watching the video, okay, this is your second assignment. After watching the video, make sure you tackle this question. All right, solve this question and then send it to me, my email. Okay, so this is a assignment. If you go through this video and you see, make sure you solve this assignment, solve it, and then send it to my mail. Okay, anytime you go through this video, make sure you work out this, show everything, how you calculate the probabilities, and show it to me. Okay, send your work, you can scan it and then send it to me through mail. So all these are chi-square goodness of fit. Okay, all these are chi-square goodness of fit. All right, so we'll start the next thing, which is test for homogeneity. Okay, so bye bye.